Hello friends, welcome back to my channel. So in today's video we will learn about the calibration procedure for the disintegration tester, and in my last video I have already covered the operation and other details of disintegration tester, so you can refer to my last video for basics, right? So the disintegration tester is used to determine how quickly tablet or capsule break down in a liquid medium under standard condition, and the proper calibrations ensure accurate, consistent and compliant results as per the pharmaceutical guidelines, right? So let's begin with the step-by-step calibration process. So friends, my YouTube channel name is Pharma Quality. So please view, like, comment and subscribe my channel to get the knowledge about the pharma quality standards and practices. So in the procedure of disintegration test and calibration, first we will discuss stroke frequency calibration. So let's discuss with the purpose. So the purpose behind the stroke frequency calibration is to verify the stroke frequency of the disintegration tester, ensuring it operates within the pharmacopoeial specification. So the up and down motion of the basket track simulates gastrointestinal agitation, making stroke consistency critical for the test reproducibility, right? So for example, here you can see the up and down cycles we need to count in the stroke frequency calibration. So let's start with the procedure. So first start the instrument and allow it to operate under normal testing conditions. Now using a calibrated stopwatch, count the number of complete up and down strokes, right, which also referred to as mechanical cycles over a 1 minute interval. It ensures the measurement is taken from a stable viewpoint to avoid parallax error during the visual counting, right? So the acceptance criteria is the observed stroke frequency must be within 29 to 32 cycles per minute as per USP 701 and other regulatory standards, right? So this is the acceptance criteria for stroke frequency calibrations. So now next one is the stroke length calibration. So let's start with the purpose. So the purpose is to verify the stroke length. So stroke length is what? The vertical distance traveled by the mechanical arm during each cycle, as we discussed in the last slide. So the topmost distance and the top button. So in between this, this will be considered use stroke length, right? So accurate stroke length is essential to simulate physiological agitation conditions required for consistent disintegration testings. So the procedure is, first ensure the instrument is powered off and when the mechanical arms are positioned below the topmost point, right? Allow the arms to move freely and settle at their lowest position under gravity. Then using a precise scale, mark the highest and lowest points reached by the arm during its cycles. Then measure the distance between these two marks with the calibrated vernier caliper to ensure measurement accuracy and reliability. So for example, you can put your this vernier caliper as per this distance, right? So this vernier caliper you can put it here as a vertical and you can measure the stroke length. So the next one is the acceptance criteria. So the stroke length must be maintained at 55 millimeters within a allowable tolerance of plus minus 2 millimeters is compliance with the USP 701 and related pharmacopoeial guidelines. So your acceptance criteria should be 55 plus minus 2, right? So now next calibration is temperature calibration. So let's start with the purpose. So the purpose is to verify the accuracy and uniformity of the water bath temperature, which is critical for simulating physiological condition during disintegration testings, right? So let's start with the procedure. So first set the disintegration tester's water bath temperature to 37 degrees Celsius, right? So the standard temperature reflecting human body condition. So generally the human body condition will be 37 degree. Now allow sufficient time for the system to reach thermal equilibrium, ensuring stable and uniform temperature distribution throughout the bath. So the temperature should be maintained at the 37 plus minus 2 degrees C, right? So now using a calibrated and traceable thermometer, measure the temperature at multiple points, including directly into the water bath and inside the beaker containing the test medium to confirm temperature consistency. So the entire water bath you can take the multiple reading, and from the beaker of the that disintegration tester where your stroke length will be commenced, right? So for each point you need to take the reading for the temperature, right? So now the acceptance criteria. So the measured temperature must be within 37.0 degrees Celsius plus minus 2.0 degrees Celsius, conforming to the USP 70 and other pharmacopoeia standards, right? So this is the your acceptance criteria. So now next one is the timer calibration. So the purpose for the timer calibration is to verify the accuracy of disintegration testers built-in timer, ensuring precise control over the test duration, which is critical for valid results, right? So let's start with the procedure. So first set the instrument's timer to 5 minutes, right? From the control panel you can set the time to 5 minutes. Then simultaneously start the instrument and a calibrated stopwatch to measure the elapsed time. So once you will start the instrument, and at the same time you need to start your calibrated stopwatch as well, right? Then observe and record the stopwatch reading when the instrument's timer completes and stops. For example, when 5 minutes has been completed from the instrument, so your calibrated stopwatch should also be stopped to match your time lapse, right? So now repeat this procedure for extended duration for 30 minutes, 1 hour and 2 hours to confirm the consistent timing accuracy across different intervals, right? So now the acceptance criteria. So the timer's recorded duration must be within plus minus 1% of the set time in accordance with the pharmacopoeia standards, right? So now next is sieve integrity check. So the purpose is to verify the physical integrity of the sieve baskets, ensuring they maintain the correct mesh structure, which is critical for consistent disintegration testing. So let's start with the procedure. So first remove the baskets from the disintegration tester carefully. Then hold the sieve against a uniform light source to enhance visibility of any defects, right? Then inspect for common issues such as broken wires, corrosion, mesh deformation, and improper welding or joining. So here you can see this is the sieve that we need to check this integrity, right? So now next one is the acceptance criteria. So there should not be any visible damage to this mesh, right? And the mesh must be uniform, tensed and securely fixed to prevent any alteration in flow dynamics during the testing. So we need to check this sieve for the integrity check, right? So next is the mesh size calibration. So the purpose of this mesh size calibration is to verify the sieve wire spacing, which ensuring the aperture size complies with the specification for accurate disintegration testings. Now next is the procedure. So first place the sieve under an illuminated magnifier equipped with the calibrated scale. So here you can see this illuminated magnifier scale generally used to measure this sieve. So to measure this sieve size, you can invert this basket, and with this help of this illuminated magnifier scale you can measure, right? And after that measure the opening between the adjacent parallel wires. So right, you can see here the parallel wires you need to measure, right? Then take the multiple reading at least 3 to 5 points across the sieve to confirm uniformity. So now the acceptance criteria is to The sieve aperture should typically range between 1.8 to 2.2 millimeter, which is subject to manufacturer specification. So always verify it with the manufacturer specification. So uniformity of the wire spacing must be maintained with a tolerance of plus minus zero point 0.1 millimeter to ensure consistent fluid flow during the testing. So sometimes you can also use the vernier calipers, right? So in the previous method, generally the companies are using this vernier calipers, or if you are having this illuminated magnifier scale, then you can also use this, right? So this is the procedure for mesh size calibrations. So friends, this is all about the procedure for calibration of disintegration tester. Thank you for watching this video.